Welcome to a division problem involving fractions. For this example, we're going to find this quotient using an alternative method where we'll find a common denominator, and once we have a common denominator, the quotient will be equal to the quotient of the numerators. For example, if we have a over b divided by c over b, then the quotient is just a over c. Notice that a and c are the numerators. Now the reason this works is because if we have a common denominator, then the pieces are the same size, and therefore it's just a pieces divided by c pieces, which should be equal to a divided by c. And we'll also find the quotient using the traditional algorithm, where instead of dividing by c over d, we'll multiply by the reciprocal, which would be times d over c. So for the alternative method, we'll start with the original problem and determine the least common denominator, which should be the least common multiple of 25 and 10. And since 50 is the least common multiple of 25 and 10, we're going to multiply negative 6/25 by 2 over 2 to obtain a denominator of 50. We'll multiply 9 over 10 by 5 over 5. Notice now in both cases, our denominator will be 50. So we'll have negative 12/50 divided by 45/50. And again, now because our denominators are the same, we can find this quotient by determining the quotient of the numerators, which should be 12 divided by 45. And we can write the quotient in fraction form as negative 12 over 45. But this does simplify because 12 and 45 do share a common factor of 3. So now we'll divide the numerator and denominator by 3 to simplify our quotient. So we would have negative 4/15. So notice for this method, once we obtain a common denominator, we do keep this as a division problem. But normally, as shown in most textbooks, we write the division problem as multiplication problem, where instead of dividing by 9/10, we'll multiply by the reciprocal of 10/9. So using the traditional method, this division problem is equivalent to negative 6/25 times the reciprocal of 9/10, which would be 10/9. And now once we have a multiplication problem, we want to simplify out any common factors between the numerators and denominators before multiplying. So notice that 10 and 25 share a common factor of 5. There are 2 5s in 10 and 5 5s in 25. And 6 and 9 share a common factor of 3. There's 3 3s in 9. And there are 2 3s in 6. But since this is negative 6, this would simplify to negative 2. And now we can multiply, knowing our product will be in simplest form. Negative 2 times 2 is negative 4. And 5 times 3 equals 15. So of course, whichever method we use, the quotient is the same. So it's up to you to decide which method works best for you. I hope you found this explanation helpful.